Hello and welcome to another video. My name is Haraldus and today I will share some object-oriented structural design patterns. The adapter pattern is like a translator. It allows incompatible interfaces to work together by wrapping one with another. As an example, I have iNewPrinter interface and an old printer class that is not compatible with this interface. To solve this, I created the printer adapter class that implements the iNewPrinter interface and takes the old printer as a parameter in the constructor. As you can see, it uses the old printer class printText method inside of the print method. Essentially all the adapter class does is wrap the incompatible printText method with a print method that satisfies the interface. It makes sense to use it when integrating legacy or third-party code that can't be changed, or when you want to reuse any existing classes but don't want to change them. The bridge pattern separates an object's abstraction from its implementation so they can evolve independently. So here's a simple example. I have an iDevice interface that defines common functions that any device might have, like turning it on and off. Then I have two classes, TV and radio, both of which implement the iDevice interface. I also have a remote control class, which takes an iDevice as a parameter in its constructor. The key idea here is that the remote doesn't care what kind of device it is controlling, TV, radio or something else. And the device doesn't care what kind of remote is controlling it. The two parts are connected through an interface, but they are independent. That's the bridge pattern. It lets you add new remotes or new devices without changing the existing code, so both sides can evolve and scale without breaking each other. The composite pattern lets you treat individual objects and groups of objects the same way. Think of a tree structure. You have leaves, which are simple end objects, and branches, which are groups that can hold other leaves or even more branches. The composite pattern says, let's give everything the same interface so you don't have to care whether it's a single object or a group. The pattern is made up of three parts. The component is a common interface for everything. Leaf, a basic object like a rectangle that implements the iGraphic interface and doesn't have any children. Composite, a group of components. You can think of it like a container that can hold other components. In this example, this is supposed to represent usage of composite pattern for a graphics editor. The draw method can be called on any of the shapes individually or on a whole group. It's perfect for tree-like structures, for example GUI elements, filter pickers, file systems, organization charts, or in this case a graphics editor. The decorator pattern lets you add new behavior to an object at runtime without modifying its original class. Instead of creating lots of subclasses for every feature combination, you wrap the original object with one or more decorators. It all starts with a component, which is a common interface for everything. The concrete component is the object that you're trying to add extra functionality to. A decorator class that has a reference to the component and adds the extra behavior. And lastly, concrete decorators, specific implementations that add features. You should use the decorator pattern when you want to add features to an object without changing its structure. It promotes flexibility over inheritance by combining behaviors dynamically. The facade pattern provides a unified, simplified interface to a system that may have multiple complex components working behind the scenes. In this example, I have classes that represent a projector, sound system, and lights. Instead of going through each of those and calling their individual methods, I have a home theater facade where I can call start movie method or end movie method, and it calls the appropriate methods on each of those classes. The facade pattern helps to hide complexity and makes the code easier to use. It's great for startup and shutdown routines, APIs, or wrapping complex libraries. The flyweight pattern helps you reduce memory usage when you have lots of similar objects. Instead of creating a new object every time, you share the parts that stay the same. This is called the intrinsic state, and you only pass in the parts that change, called the extrinsic state from the outside. The character factory has a dictionary of characters that are stored. When you call the getCharacter method, it checks if you already have that character created. If yes, then you reuse the same one. If no, you create a new one and store it in that dictionary. You should use the flyweight pattern when you have a large number of similar objects. These objects take up a lot of memory. Many of them share the same data. For example, thousands of characters on the screen in a text editor or hundreds of trees in a game. The proxy pattern is used when you need to control access to another object. You don't interact with a real object directly. Instead, you go through a proxy, a middleman that decides whether or when the real object should be used. Common proxy types include virtual proxy for lazy loading, protection proxy used for access control, and remote proxy for distributed systems. Here's a very simple example of a protection proxy. iDocument is the subject interface. Secure document represents the real subject. The document proxy checks the user access. If the user is authorized, it then lazily loads the actual document, so the real object isn't created until it's actually needed. The proxy acts as a middleman. It performs extra checks, adds extra functionality, or even blocks access, all without changing the real object. You should use the proxy pattern when you need to control or manage access to another object. The repository pattern acts as a middle layer between your application and your data source, for example a database. It encapsulates the data access logic, allowing you to treat data like objects and focus on business logic. As an example, I have a user class, and in my repository interface I have generic methods for adding a user, getting a user by ID, getting all users, and removing it by ID. In my experience, the repository pattern is very useful in my day job. It allows to easily swap data sources, unit test by mocking repositories, and centralize data logic. Are you familiar with the structural pattern that I haven't mentioned, or my explanation of any of these didn't make sense? Feel free to leave a comment below. Thanks for watching, and see you again in the next one.